Okay, so we have here our second problem for parallelograms. So we have here word problem number 2. Lola Natalia wants to create a chicken pen in her free yard. So given below are the vertices of the parallelogram shaped like a chicken pen, which has 4 vertices, RL, and then RL and G and P. So find the value of x. So we need to find the value of x first. Okay, on this given angle, and also this given side, and also we need to find the measurements of side RP and LG. So to do that, okay, so let's start first with our let's start first of what we know here. So we have here a parallel line, a pair of parallel lines, and we have here a diagonal that also acts as a transversal, and therefore we have here two alternate interior angles, angle PRG and angle LGR. So therefore we can say that angle RPG, okay, is congruent or is the same or congruent as LGR. And by substitution property of equality, we can say that angle RPG, this should be angle PRG, okay, angle PRG, okay, angle PRG, which is equal to 82 degrees, should be equal to angle LGR, which is 9x plus 4. Okay, so we got that by first stating that the measurement of angle PRG, okay, the measurement of angle PRG, okay, must be equal to the measurement of angle LGR. From here, we can solve the value of x. Okay, so that's going to be 82 minus 4 is equal to 9x. Okay, and that's going to be 9x is equal to 78. Okay, and what's 9x divided by 78? Or 78 divided by 9? That's going to be 26 over 3. Therefore, the value of our x is equal to 26 over 3, or 8.67, or 8.67. Therefore, we can also say that line segment RP, is equal or congruent to line segment LG. So therefore, if we get the measurement of LG, we also get the measurement of RP. And LG measures, okay, line segment LG measures 5x minus 7 meters. Okay, so we can substitute the value of x here. So that's going to be 5 times 26 over 3 minus 7. And that'll give you, okay, LG is now equal to 109 over 3, or 36.33 meters. Okay, so that means line segment RP and LG on the chicken pen of Lola Natalia measures 36.33 meters, and the value of x is equal to 26 over 3, or 8.67. Okay, let's go right ahead to our third word problem. William wants to create a parallelogram shaped smartphone. A smartphone that is shaped like a parallelogram. But to do that, he needs to find the diagonals of the parallelogram first. So given on the illustration on the right, okay, so we have here on the right are the side measurements of the diagonals. Find the measurements of sides CU, UP, UA, or AU, and UN, and of course the diagonals CP and AN. So to do this, of course, we already know the property of a diagonal, that their bisectors, okay, their diagonals bisect each other. Okay, so line segment AN or diagonal AN is bisected by CP, and also CP is bisected by AN, that diagonal. So therefore, CU and UP are congruent to each other. So let's write that. Okay, so CU is equal to UP or congruent to UP, and AU, okay, AU is congruent to UN. Okay, and from here we can now solve for the value of x and y. So the value of CU is 5x minus 1. Okay, 5x minus 1 is equal to UP, which is y. And the value of AU is 2y minus 15. Okay, and UN is equal to 3x. Okay, and you can look at this relation, guys. So y is equal to 5x minus 1. We can directly substitute that here on this formula. Okay, so that will give you 2. Okay, so that will give you 2 times y, which is equal to 5x minus 1. Okay, and then minus 15 is equal to 3x. Okay, and then we can distribute this 2 right here. So that will give you 10x minus 2 minus 15 is equal to 3x. Okay, and we can also say here that 10x minus 17 is equal to 3x, and if we transfer 3x here, that's going to give you 10x minus 3x is equal to 17, and this will give you 10x minus 3x, that's going to give you 7x is equal to 17, and if we divide both sides by 7, we get that the value of x is equal to 17 over 7. Okay, so that's the value of x. And from here, we can substitute that value to this equation so that we can get the value of y. Okay, so that's going to be 5 times 17 over 7 minus 1 is equal to y. Okay, and that will give you a value of 78 over 7. Okay, so that's the value of y, or that will be equal to, okay, so 5 times 17 over 7, okay, minus 1, that's giving to you 78 over 7, or 11.14. Okay, so y is also equal to 11.14. And from here, we can now solve for the values of the side measurements of the diagonals that's been bisected. Okay, so since we said that CU and UP are congruent to each other, therefore their values are just going to be equal to y, which is equal to 11.14 meters. So that means CU and UP measures 11.14 meters. And AU and UN will measure 2 times 11.14 minus 15, because that's going to be 2y minus 15, which is the measurement of AU and UN. So that will give you 2 times 11.14 and then minus 15, so that will give you 7.28. So that's the measurement of AU and UN, 7.28 meters. And if we multiply both of these numbers by 2, we get the measurement of the diagonals CP and AN for William's smartphone. Okay, so that's going to be one giant smartphone, a very big smartphone, because it's measured in meters. So 11.14 times 2, so this will give you 22.28. Okay, 22.28 meters. So maybe William is trying to make the biggest smartphone in the world. So that's 22.28 meters. And for the UN, so that's going to be 7.28 times 2. So that will give you 14.56 meters. Okay, so these are the dimensions of the diagonals. Okay, these are the dimensions of the diagonals, or the values of the diagonals of William's parallelogram shaped giant smartphone. So the diagonals are 22.28 meters and 14.56 meters. Okay, so lastly, we have here an enrichment problem. Okay, so this is a hard geometry problem given to Chinese students in the 5th grade level. Okay, so that is one of the difficult problems that's used to determine gifted students in China. Okay, for 5th graders. So for this problem, we want to know what's the area of this shaded blue region right here, given only these 4 measurements: 79, 72, 8, and 10. So how do you think, guys, can we find the measurement of that blue shaded area? Okay, so this problem, okay, find the area of the blue shaded triangle on the upper left corner of the parallelogram given parallelogram ABCD. Okay, so this is still part of our module, but more on area, and the area of the 4 shaded selected sectors. Okay, so to solve this problem, first we need to label the parts, the missing parts of the parallelogram, or the missing sectors. So we call these areas sectors. Okay, so we have here sector A. Okay, so we name this as sector A, sector B, sector C, sector D, sector E, and sector F. And we also named the triangle, the blue shaded triangle, as sector X. Okay, and still we have these 4 we have these four values. To solve this problem, we need to use our imagination. Okay, so a parallelogram, when you flip a parallelogram, or when you rotate it 180 degrees, so its base, okay, its base length and its altitude are still going to be the same. Okay, but the orientation is just from portrait, okay, from a vertical altitude, and when you transform that into, or when you flip it 180 degrees, the altitude is still going to be the same. You just kind of flip the parallelogram. So this is the main idea on how to solve this problem. You need to be able to see the pattern, or the relationship between the vertical altitude and the horizontal altitude, which are still the same. Okay, so after flipping it, and also the bases are also the same after you flip the parallelogram. Okay, so if you have your vertical altitude, and so it has a base sub 1 length, okay, at its length. Okay, so and when you flip it, it's going to be the width, and the vertical altitude turns to a horizontal altitude. And of course, the area of a parallelogram will always be equal to base times height. Okay, but since there are two triangles here, therefore we can divide that by 2, and therefore we get the area of a parallelogram, which is base times height divided by 2. We get the area of the two triangles here. Okay, so the area of the two triangles, okay, so if you have here the entire parallelogram, you get base times height. But since we only have the area, we only want to get the area of these two triangles here, then therefore we have to divide the area of the entire parallelogram by 2 to get the area of these triangles here. So why am I saying that? Because it's important to note that, because if you look closely, we can form a relationship here. Okay, so this is triangle AB. Okay, so let's look at this triangle. Okay, so it has a base. So it has a base here, and it also has a height. And also we can say that this triangle is similar to this triangle. Okay, so we have here our first triangle, so this red triangle, so it covers the entire base times height. Okay, so that means this entire base is covered by this triangle. And also we have here another triangle with this base. Okay, it has this base, and also this one, also this triangle has this base also. Okay, so we can say that these two triangles, triangles 1 and 2, this entire two triangles is similar, or the same, or has the same area as this big triangle here, because they both cover the same basis of the parallelogram that we have. Okay, so therefore we can equate those two triangles. So we have here for the first one, the two triangles themselves with the same base and the same height, and also the same triangle when you flip it, the same base and the same height. So therefore we can create a formula. Okay, we can create a formula for finding the area of these two triangles here, which is similar to the area of the entire triangle here. So that's going to be by adding the sectors. Okay, it's going to be x plus a plus 72 plus b plus 8 is equal to, okay, to the triangle that we've rotated. Okay, that still has the same base as the first two triangles when added together. So that's going to be a plus 79 plus b plus 10. And if we do our transpositions here, this will give you x plus a minus a, and then plus b, and then minus b is equal to 79 plus 10, and then minus 72 minus 72, and then minus 8. Therefore, this a's cancel out, and therefore x is equal to 9. Okay, so that's the value of our x here. So x is equal to 9. So after solving that, as you can see, it might look like a very difficult problem at first if we don't really draw the what do you call those triangles. So if you try to solve it like ahead, or like you attack the problem ahead, so it will be difficult to solve for the value of x. But if we try to form these patterns here and identify that the area, okay, is that the areas of this big triangle and these two smaller triangles are the same, we can form a relationship that gives us these equations, and therefore leading us to this value x is equal Good job, Max I students. Very good.